Good afternoon, dear CEO and Senior Network Administrator. My name is Emile Creton. I am a Junior Network Administrator here at Swift & Bacon Publishers. The purpose of this presentation is to show that I have the knowledge required to build an effective network solution that will satisfy the company needs and wants. For that, I will be talking about the core principles of networking, protocols, and topologies. So first, here is a summary of what I will be talking about. First, network types. Network types is the way we connect devices together so that they can communicate with each other. So in this presentation, I will be talking about three of them: wired, wireless, and hybrid. To start, wired is the way we connect devices together so that they can communicate with a physical cable. An example can be the Ethernet cable. So the benefits of the wired is that is enhanced speed, so fast data transmission due to the fact that it's connected with the cable. So it's stable and direct connection. Next, we have increased security. Again, the data do not travel through air. Suitable long distance, it can go up to 100 meters as compared to 45 meters with wireless. Lastly, no interferences by radio frequency or physical obstacles. And on the constraint, less mobility because computers are connected physically, so employees might be tied down to a specific location. Heaps of maintenance, there's often maintenance with the cables. Time consuming to install can go from few hours to few days. It can look untidy to have cables laying around and cause trip hazards, which can cause disconnection and data loss. Next is wireless, is the same purpose, to connect devices together so that they can communicate but without any physical connection, so it's air travel. So first benefits, it's global coverage. We can have wired networking in rural and remote places, which wired cannot work. Then flexibility or just mobility, we can have devices connected anywhere. Easy expansion, so high scalability. We can add devices quickly and without any hardware necessary. And lastly, device compatibility. We can add any devices to the wireless network. On the constraint, it's easy to act since it's air traveled. Open to interference, again because it's air traveled. Potential health concern. This can be controversial, but people believe that wireless network can be emitting radioactive, electromagnetic radiation. And lastly, slow speed at longer distances. Hybrid is just the last one. It's a combination between wired and wireless. The benefits and constraints apply to both. So flexible due to wireless. Use for vast network. We can with hybrid we can have a huge network. Scalable again due to wireless, and high reliability. If one of the network fails, we have a backup. On the constraint, it's just very complex design, difficult to install, and high cost. Next, network standards. It's just a set of rules that devices and computers uses to talk with each other over the network and the internet. So in this presentation, I will be talking about OSI TCP/IP 802.1x. So first of all, OSI is Open System Interconnection. It is the blueprint that helps computers talk with each other by dividing the communication process into 7 layers. So the benefits is a guidance tool to develop a network model. It's basically a manual that helps you build your own model. Then structure framework. OSI offers a stable and organized way to understand network. Makes troubleshooting easy since it's divided into 7 layers and each layer has its function. It's easy to see where the problem is coming from, and used in teaching tools. So education use a lot of OSI to explain network. On the constraint, it's overly detailed and complicated because there are 7 layers and most of them repeat each other. Network have evolved, so it has become a little irrelevant. And lastly, TCP is often preferred because it's more practical than theoretical, like OSI. OSI is less reliable in real life. Now let's talk about TCP/IP. It's transmission control protocol. It's the internet language. It's on the benefit you can see that it's industry standard, universal language, so computers in the world can understand the language. A public rule book, so it's neither owned nor controlled by any individual, and everyone can use TCP/IP. And lastly, compatible with the majority of devices, so it's easy for any device to use TCP/IP. On the constraint, it lacks security. OSI provides more security than TCP/IP. Complex with larger network, since it's difficult to troubleshoot any problems. And IP shortage needs to transfer to IPv6 and can be time-consuming and costly. Lastly, 802.1x, it's an authentication protocol. It's just to enhance security with different ways, which can be flexible since we can use passwords, OTP, username, anything. It controls access with extreme ways, so that not everyone can access it. And this can be a constraint because it can create false positive where it's legitimate devices that are refused. And then limited support. So some devices do not are too modern for, not too old for 802.1x. And lastly, single point of failure. If this radio server of 800.1x fails, the whole standard fails. On this slide, I will just be talking about networking topology, communication, and bandwidth. The network topology is the physical or logical layout of the devices and connection. So there's star, ring, bus, mesh, tree, but in this presentation I will be talking about what I think are the 3 most important. So star, bus, and tree, ring, sorry. So first, star is the physical layout is when all devices are connected to a central node, which can be a switch, hub, or a router. And it's a unicast communication, so one-on-one communication, but that I will be talking about it later. So the advantages are extremely reliable, since if one cable fails, the rest of the device, the rest of the network will still continue to work. High performance due to the lack of collision. So since it's unicast communication, it's one-on-one communication, so there's lack of collision, user-friendly, easy to add or remove any devices, and fault detection, it's easy to see where the problem is coming from. On the disadvantages, it requires more cable than linear bus. Central dependency, so if the central node fails, the whole network will stop to work, and then potential damage with the cable, so if it's accidentally cut or any other problem with the wires. Then on ring topology, the same principle is the communication, but devices are communicating or are displayed on a circular data channel. So same unicast communication, and the advantages of a ring topology is there are no limitation of numbers of devices. You can place as much as you want on how many devices you want, you just have to move the adjoining device. Next, high data speed of transfer, and the program will neither stop nor get slower if you add any devices. One directional data flow, so it can go clockwise or anti-clockwise, which is good because since it's one directional, there is no collision nor congestion. And on the disadvantages, it's highly expensive due to the hardware, privacy issues because data travels in a circle, so every device gets data, and if there's any sensitive data, it can be bad. Unidirectional paths with workstation can mean that if one device breaks down, the whole network will shut down, and the same thing with a cable failure, the whole network will stop. And lastly, bus topology is just how devices are attached with a single cable called the bus. There is a broadcast communication, so one to all devices, and the advantages are that it's easy to add new devices, just adding two cables. Troubleshooting is easy because you can quickly see where the problem is coming from. It's cost effective since it does not require much data, much hardware besides the cable bus. Easy to add or remove any devices and will not affect the others. On the disadvantages, it's not suitable for large networks since it is prone to congestion and with traffic. Unlimited cable length, limited cable length, and it gets slower as you add new devices on it. And it's the slowest topology of them all. And lastly, high packet loss, data do not always reach destination. And this is just a quick talk about communication and the requirements on communication. It's just the data traffic and how devices need to connect with the network. So there's three types: unicast, multicast, and broadcast. Unicast is one-on-one communication, so the sender sends to only one receiver. Advantages is more secure, but slow data transfer. Multicast is one on a selected group of people, so sender sends to some devices, but not all of them, so fast data transmission, but not as secure as unicast. And broadcast is a type of multicast, so it's just the sender sending to all of the devices, and the advantages and disadvantages are the same as multicast. On bandwidth requirements is just the capacity of the network to transfer data from sender to receiver. The highest the bandwidth, the highest the rate of data transfer. So it's basically how much and how fast can you send the data. Next, just principle and protocols and how protocol enable an effective network system. First, let's talk about what is IPv4. It's just the Internet Protocol, which is a set of rules that allow us to connect our devices to the web. IPv4 is one of the layers of TCP/IP. Is on layer 3, and why do we use IPv4 is just for safety reasons, because the main task of IPv4 is to block is to send blocks of data to the from sender to receivers. Computers are identified with an IP address. The advantages of IP address is widely supported by networks, equipments, operating system, and all kinds of devices. It's backward compatible with old system and devices. And lastly, tons of documentation, expertise, and tutorials on IPv4, which is useful for engineers and network administrator. Disadvantages is only 32 bits, so gives roughly 4.3 billion unique addresses, which causes a global scarcity. Due to high demand and scarcity of IPv4, it is getting very expensive. And lastly, with the internet growth, the IPv4 is getting inefficient and slow. Now let's just talk about IPv6. It's just IPv6 was created to overcome the shortage of IPv4 and to ensure the internet's growth for the future. So what are the benefits of IPv6 over IPv4? It's just that it's 128 bits, so it gives an almost infinite amount of unique addresses. It also eliminated NAT, which is network address translation, which was used for homework network, home network, which was translating with the web for the address. This they got rid of, so it's useful now. And then enhanced data authentication, encryption, and which increase security. They have a built-in IPsec support, which is digital lock and keys. On the disadvantages, it's not backward compatible with IPv4. So if devices using IPv6 needs to use IPv4, they need configuration. Switching IPv6 to IPv4 is time consuming, costly, and lastly, complex address. It's not user friendly because it's difficult to remember. Quick and small talk about HTTPS is just to ensure information received and sent, which needs to be kept private. Uses encryption to protect data from getting intercepted or modified, and to keep data online confidential. So the advantages are basically the purpose of it. So encrypts, verifies that the website is legitimate, and secures online transactions, so make online payment possible. And disadvantages can be costly to maintain and acquire an SSL and TLS certificate to have HTTPS. It's more technical than HTTP. And lastly, older browsers may not be able to use HTTPS due to its modernity. Now, let's talk about few networking devices. The purpose of, for example, a router, it just directs data traffic to intended direction between devices and network. It assigns and manages an IP address to communicate with each other on the network. And the advantage is router organized by separating into few parts in the network, and prioritize the access of more important uses such as phone calls over less important uses. Disadvantage is complex to set up and expensive. Next, on the switch, just manages data traffic on the local area network. It just directs the data to the device that only needs it, so it reduces the unnecessary data traffic. So advantage is fast data transmission, isolate the connection, which increase security, and disadvantages, high cost and complex setup. Purpose of firewall is just control. So the purpose of firewall is to control and maintain incoming and outgoing data traffic. The advantages are enhanced security and personal data secures personal data. Disadvantages may block legitimate access and often requires too much expertise to maintain it. next and last, repeaters amplifies and retransmit network signal over long distances. So advantages: allow signal farther away, easy to install, and minimal configuration. On disadvantages, the signal may degrade over long distances and does not protect data. The repeaters do not protect the data, so it just retransmits data further away. Last, bridges is just hardware that reduces congestions and filters the traffic. It is like it isolates data traffic and divides the network into parts, so it just reduces collision. And disadvantages: limited stability, so it might reduce the performance with multiple devices, and it's complex, not as effective as routers. On network server types, we will talk just about IoT gates, which is how we are able to connect cars, air conditioning, and fridges to a software. Next, domain server is just translating human domain names into IP. So, for example, google.com into IP, and it's hardware that stores just the information into something called domain name server. And then purpose of web server is just store and deliver web pages to clients and their requests. Lastly, what the purpose of a file is just a digital container where you can store videos, photos, and anything. Database is a piece of hardware that allows the sole purpose is to store and manage the database. And then lastly, access of permission is just how it says is rules and settings that determine who is allowed to access specific resources on a computer. Last slide is just to understand how hardware and software depend on each other. So software configures the hardware, and it's just that hardware gives the physical connection, and software manages the communication and settings. So an example would be the Wi-Fi adapter that we can plug to the computer, and then the networking software will just manage the Wi-Fi by using a security protocol such as PA2 and WPA3. So that's it. And to conclude, designing and building an effective network solution depends for a large company as Bacon, Swift, and Publisher requires sufficient knowledge to be talking about the core networking. The core principles of networking, and as a junior network administrator, I think I can read it. Thank you.